Guys, welcome back. In this video, we're going to add a camera follow script. So to get started, I'm going to come up here and create an empty game object that I will just call camera follow. Once that's been created, I'm going to reset the position of this object, and then I will parent my main camera onto the camera follow object that we just created. Once that's been done, I'm going to select the camera follow object, and I'll just add a new C# script called camera follow. I'm then just going to double click on it to open it up inside of my text editor. Alright, so the first thing we need to do is to take a reference to the player's transform component so that this script knows what it needs to follow. So to do so, I'm going to create a public variable so that we can assign the value inside of the Unity inspector. Then the type is going to be transform, and I will just call it player transform. Okay, next, inside of our void start method, I'm going to set the current position of the camera to be equal to the player's position, so player transform dot position. So that like that, right at the start of our game, the player and the camera are at the same position. Awesome. Next off, we have to update every single frame the camera's position to be equal to the player's position, and we want to do that in a smooth manner. So it's very simple. Inside of our void update function, we're just going to set our transform dot position equal to vector2.lerp. So vector2.lerp is a function that lets you smoothly move from one point to another based on a speed. So the first parameter that we need to pass in is our current position. So that's just transform dot position. The second parameter is the position that we want to move towards to. So in our case, it's the player transform dot position. And lastly, we need to put a speed value. So I'm just going to come up here and create a new variable, a new public float variable called speed. And I'll put it as my third parameter. Okay. I'm just going to wrap this line of code inside of a if statement, checking if the player transform is not equal to null. Another case, if the player transform variable exists. So we're doing this as a safety measure because later on the player will be able to die, and this line here will return an error message if the player transform is null. So we just have to check if the player transform is not equal to null, and then we're good to go. Okay, so if we now save our script and go back to Unity, we can just drag and drop our player character onto the player transform slot. And then for the speed, I recommend you use 0.125, but you could test this out and use anything you would like. If we now press the play button, you'll see that we can move our player around and the camera follows the player. Awesome. So there's one little problem, is that if we get near the edges, we can see all the ugly background color, and we don't want to do that. We want our camera to have a restraint so that we don't see this ugly area. So it's very simple to do so. So we're just going to create 4 public float variables: min_x, max_x, min_y, and max_y. Alright, so inside of our update function, I'm going to create a float variable called clamped_x. So clamp just means, clamp is just the same as restraint. So I'm going to create a clamped_x variable, which is going to be equal to mathf.clamp. And the first parameter that we need to pass in is what do we want to clamp, what do we want to restrain. So in our case, that would be the player transform dot position dot x, because we're doing the clamped x. And then we're going to restrain it between our min_x and our max_x variable. So what this line basically does is, imagine we've got a min_x of -5 and a max_x of 10. And let's say our player transform dot position dot x is equal to 15. Well, instead of being it's equal to 15, it will just be equal to the max_x variable, in other words, 10. Okay, we're just going to copy and paste this line underneath, and we're going to do the same for the y. So float clamped y equals mathf.clamp player transform position dot y between min_y and max_y. And now when we're going to update our transform position, instead of using the player transform dot position, we're going to create a new vector2, and we're going to pass in our clamped X and our clamped Y variables that we just calculated. Perfect. So now if you save your script and go back to Unity, so to fill out these variables, it's very easy. You're just going to select your camera for game object, choose the transform tool, and you're going to move it all the way so that the white border here hits the edge of your map. So in my case, that would be something like negative 12.5. So I'm just going to put for the min x negative 12.5. For the max x, it's going to be the same, so around 13. For the min y, I'm just going to bring it down, and that's something like negative 18.5. And for the max y, it would be positive 18. Okay, so now let's reset the position of our camera, and if we press play, you should see that the camera position is getting restrained and we don't see anymore the ugly background color. Perfect. The last thing we need to do is to restrain the player's position so that he doesn't go off the map. Alright, so for that, I'm just going to come up here and create an empty game object that I will call stopper. Then we just need to add a box collider 2D. So a collider is basically just an invisible wall. So for now, the collider is very small, as you can see, represented with this green box. So we're just going to scale it up, and now we have to place it around the edges of the map. So I'm just going to place it on the left here. I'm going to scale it up, and there we go. Now I just have to duplicate it with Command D or Control D if you're on Windows. Duplicate it again. Scale it, and then the last one. Perfect. Lastly, we also have to add a box collider to the player so that these invisible walls can function correctly. So I'm just going to select my player and add a box collider 2D to him as well. And now we have to shape it correctly. So I'm just going to press on this edit collider button, and I'll just move these points to shape the collider as I like. Okay, now if I press the play button and move to a border, I'll see that the camera gets blocked and the player also gets stopped by the stopper invisible walls that we just created. Perfect. Okay, that marks the end of this video. I'll see you in the next